Okay, Assalamualaikum and good day everyone. So today we are going to continue with the next lecture of topic 2, which is lecture 2, focusing on the techniques of integration. So the second subtopic. So the learning outcome for this lecture, at the end of the lesson, students should be able to find the integral by using substitution method. Okay, so the integral by substitution, which is the integration of f of gx, so a function of f of gx multiplied by g prime x is equal to, can be rewrite as integration of f of u respect to u, where u is equal to g of x. How do we get from this form on the left side to the right form? Okay, so our main focus now is to modify the equation by representing some of the terms, some of the expression as another variable, so that the question will become easier to integrate. So that is our focus by using substitution. Okay, integration by substitution. The simple approach of choosing u. So integration by substitution, these are some of the example of the question that we can use substitution to solve the integration. Okay, so first of all, 4x plus 3 all over 2x squared plus 3x minus 6 all to the power of 2. So we have a power at the denominator. We cannot apply quotient rule. We don't have quotient rule in integration. And then the second one is 6x minus 2 all multiplied by e to the power of 3x squared minus 2x respect to x. And then we have x minus 2 multiplied by x squared minus 4x all to the power of 6, which is this is in the same form lah. Okay. And then the last one is natural log of x plus 5 all to the power of 4 all divided by x plus 5. Okay, so this is also in the same form. Okay, so if you can see here, this expression, the first, this is the first one, the second one, and the third one. Actually, we have the same form. The only difference is that the function inside the bracket, and then the power itself. And also, for the third one here, we have natural log inside the bracket. And for the fourth function here, we have exponential. So some of these expression or question, actually we have learned how to solve it, right? Why? We can use for this number 1 and 2, we can use the yes, the special form of integration of f prime x multiplied by f of x all to the power of n respect to x. But now we want to try to use substitution method. And exponential also, we have this function f prime x multiplied by e to the power of fx respect to x. So this 1, 2 and 4 is special form of integration, basic integration. Okay, let's see how do we solve this type of expression, this type of question. The first one we choose from the denominator because the denominator has a power of 2. So u will be 2x squared plus 3x minus 6. So this is the one we choose to substitute. Okay, so we substitute the 2x squared plus 3x minus 6 with u. And then for the second one, exponential, we took 3x squared minus 2x. Choose from the exponent. Okay, if we have denominator, then we choose from the denominator. If we have the exponent, we choose from the exponent, which is u equal to 3x squared minus 2x. And then the third one, we choose from the log, from the expression of log. Everything inside the bracket of log, we choose u equal to natural log of x plus 5. And lastly, we choose from the expression with index. Okay, actually the first one and the last one is the same. Both has index. Okay, u equal to x squared minus 4x. Okay, so let's see some example. By using substitution method, solve integration of 4x minus 3 or multiply by 2x squared minus 3x plus 2 all to the power of 5 respect to x. So if we follow what we see earlier, we use the u, we choose the u. For this one, we have index. So we choose the u inside the bracket with the index. So our u is equal to u equal to 2x squared minus 3x plus 2. And then step 2, find the derivative. So differentiate u respect to x. So we get u du dx equal to 4x minus 3. And then separate according to variable u and x. Okay. So du is equal to, we can write down it as 4x minus 3. So u stay together with u, x stay together with x. Now, what we can do? So we see anything inside the question that has this form. 4x minus 3 respect to x. So that will be the du. Okay? So, step 3. Substitute all expression of x in the original integrand by substitution u. Strictly no mixture of x and u in the integrand. So, for this one, you have to make sure when you change into variable u in this part, that everything will be changed into u also. You cannot, part of it is u, another part is x. No. You will be penalized. So, for this one, if we put 2x squared minus 3x as u, then automatically we need to change the dx and 4 minus 3 into du. Okay, so that's why it will be u multiplied by u, but remember we have this power because our u is only 2x squared minus 3x plus 2. So we still have 5. So u to power of 5 multiplied by du. Why? Because 4x minus 3 dx is equal to du. So now we have an expression that really simple that we can directly use the basic rules of integration. So perform integration in terms of u. So integrate u respect to u, we can do that. So respect to u. So u to power of 5 is in the form of integration of x power of n respect to x, right? So directly use the basic rules of integration. We get u to power of 6 over 6 plus c. So that's step number 4. And lastly, because the question is in the form of x, then we need to replace back the u with x. So what is u? U is equal to 2x squared minus 3x plus 2 all to power of 6 divided by 6 and then plus with c. So that is the step in solving integration by substitution. So let's continue example 2. Integration of 3x plus 5 multiplied by square root of x plus 5 respect to x. Okay. Wow, this question why this is x, this is x. If we directly just calculate, then we know already that, oh, differentiate x, we get 1. But here we have x, so how? Okay, so first of all, don't panic. Okay, what we need to do, just follow the step. First, we need to let u equal to what? So the criteria, we see the one with the index. So what is the one with index? We have x plus 1 to power of 1 over 2, right? Okay, this square root is equal to power of 1 over 2. So we choose u equal to x plus 1. And then what is du? Du is equal to du dx. So differentiate u respect to x, we get du dx equal to 1. So when we separate the du with u from x, so we get du equal to dx. Okay, so that is the first step. If you want to replace, then we can replace the dx and the x plus 1. How about this one? Because we need to replace back x with u, everything must be in u, then we can find what is the connection x and u. The connection of x and u is u equal to x plus 1. Then x is equal to u minus 1. We can replace the x with u minus 1. So everything will be in u. Okay? So, what do we get here? what do we get? So suppose differentiate this one, du dx is equal to 1, then du is equal to dx. So x plus 1 can be replaced with u, and then what is 3x plus 5? It's a 3 of u minus 1 plus 5. And then x plus 1 is u to the power of 1 over 2, and dx is equal to du. Then after that, what we can do? So everything inside the bracket here, we can expand at 3u and minus 3, and then plus with 5. So we have 3u minus 3 plus 5 multiplied by u to the power of 1 over 2 respect to u. And then we also can, this one will be plus 2. Then we can expand again, apply the rule of indices. So 3u multiplied by u to the power of 1 over 2 will be 3u to the power of 3 over 2. Right? Expand 3u multiplied by u to the power of 1 over 2. We get 3u to the power of 3 over 2. And then 2u multiplied to the power of 1 over 2 respect to u. Now, what we can do is to use the basic integration rules. So integrate u to the power of 3 over 2. We will get u to the power of 5 over 2 over 5 over 2, which is these two will be multiplied by 3. And then the right side we get u to the power of 3 over 2 over 3 over 2 plus c. And then change into the nicely fraction. So we get 6 over 5 of u to the power of 5 over 2. Okay, so step by step we get 6 over 5 of u to the power of 5 over 2 plus 4 over 3 of u to the power of 3 over 2 plus c. But now because we want the answer in terms of x, because the question is in terms of x, then replace back the u with x plus 1. That's why we have 6 over 5 of x plus 1 to the power of 5 over 2 plus 4 over 3 multiplied by x plus 1 to the power of 3 over 2 plus c. Okay, so that is example 2. Example 3. Okay, we have a fraction but we don't have any power. So which one we should choose as our u? So the one at the bottom. If we don't have any log, so then we took the denominator. So we let u equal to 5x cubed minus 7. Okay, we also use the formula, right? So we know we have the special formula. But now I want to try to use the substitution method. So we use u equal to 5x cubed minus 7. Then what is du dx? Du dx is equal to 15x squared. So what is du? Du will be 15x squared dx. But in the question, we have this part we can change into u, right? But this part we only have x squared dx. So we only have x squared dx. So this 15 actually we can bring it to the left side. So that's why we will have x squared dx equal to du over 15. So we can replace the x squared dx as du over 15. So what do we get? After replacing the u and du, we will get integration of du 1 over u multiplied by du over 15. So this 1 over 15 will be only just the coefficient. We can take out. Now we want to integrate 1 over u respect to u. So integrate 1 over u, what do we get? By using the basic rules, we get natural log of u, natural log of absolute u plus c. So replace back the u with 5x cubed minus 7. We have 1 over 50 of natural log of 5x cubed minus 7 plus c. You can check by using the special formula. So let's say we have a fraction, right? So fx is equal to 5x cubed minus 7. Suppose f prime x should be equal to 15x squared. But what do we have? It's supposed to be 15x squared over 5x cubed minus 7 respect to x. But we don't have 15 here, so we have to multiply by 1 over 15. So that's why we have natural log 1 over 15 of natural log 5x cubed minus 7. So the answer will be the same. Okay. So let's say the question asks you to find it by using solve the function by using substitution method. So you cannot use the special formula method. So you cannot use this one. You have to use substitution method. If not, then you didn't answer the question. Okay. So let's continue. Example 4. Find integration of x e to the power of x squared respect to x. Okay, so we see that this is an exponential. You can also use the basic formula, the special formula, right? But now we want to use the substitution method. If it's an exponential, then we take the index of the exponential, which is equal to x squared. Then differentiate du respect to x, we get 2x. Okay? But in the question, we only have this is e to the power of u, and then we only have x dx. So x dx, so we need to bring x and dx together. So other than that, we'll bring to the left side. So we have x dx. So these two will be du over 2. Okay? So that's why we have du over 2 equal to x dx. So we replace e to the power of x squared to e to the power of u. And then x dx replaced with du over d2. Okay? So, how to integrate exponential? So these two will be the coefficient 1 over 2. Integrate e to the power of u respect to u. Directly we get e to the power of u again. So that's why 1 over 2 e to the power of u is equal to x squared. So e to the power of x squared plus c. So because we did integrate e to the power of u, we get e to the power of u. Then we replace back u with x squared. So that's for example 4. And continue with example 5. So find the integration of 3 natural log, integration of 3 multiplied by square root of natural log x squared divided by 2x respect to x. Okay. So is this 3 multiple or 3 cube root? Okay, let's see. So this is everything to power of this log x squared to power of 1 over 2. Okay. So we cannot use the law of logarithm that this is x squared to power of 1 over 2. No. It's everything natural log of x squared to power of 1 over 2. So what we need to do? Okay. So we take the one with log. Okay. The one with log inside the power, inside the bracket of the power lah. The one with the power, so we take everything inside the bracket. So which is natural log of x squared. So to differentiate, we need to find du dx, right? So we need to differentiate natural log of x squared. It's the same as 2. We can apply the law of logarithm will be 2 natural log of x, which is after we differentiate, we get du dx equal to 2 over x. So because we want what we have here is x dx over x. So these two, we get du equal to 2 over x dx. Then we want dx divided by x only. So these two will bring to the left side. So we get du over 2. So we can replace the dx over x as du over 2. And then this natural log of x squared as u. How about these 3? Okay, let's see. Sorry. Okay, so we get 3 of u. So this 3 is just coefficient. And this 2 also just a coefficient. So we can take it out as the coefficient of the integration. And then this natural log x squared is u. And then to power of square root. So to power of 1 over 2. And then x dx divided by x is du over 2. So the coefficient here we have 3, 2, 2. So 3 over 4. Integrate u to power of 1 over 2 respect to u. So respect to u, can we integrate u to power of 1 over 2? Yes, of course, yes. We get u to power of 3 over 2 over 3 over 2. And then plus with c. And then simplify, these 3 can be cancelled out. These 2 will be here. So 1 over 2. So 1 over 2 of u to power of 3 over 2. So we replace back u with natural log of x squared. We get 1 over 2. 1 over 2 of natural log of x squared to power of 3 over 2 plus c. So here they replace back with u with natural log of x squared and then simplify. Okay, that doesn't matter which one you want to simplify first. Okay, so finally you get the answer, the same answer. Okay, so this power you cannot multiply because this 3/2 is the power of log itself, not the one inside the log. Okay, so this is our final answer for example 5. So that's all for the integration by substitution. I hope you can try tutorial number 3 and I will give you lecture 4 shortly. Okay, so thank you class. Good. Oh, don't forget to upload your answer for question number. We start with question number 5, 6, 7, 8, right? So 5, 6, 7, 8 to 4, 5, 1, 2, 3. Later I will put it in Telegram. Okay, so thank you class.